All right, so for the first one, first of all, the directions just said to simplify and then write answers in standard form. It's not going to tell you exactly what to do. You got to know it by looking at, based on what type of question it is. So for number one, you've got the numbers at the front you're going to distribute. You also have a negative you're going to distribute. So I would distribute these. I'd get 6i minus 4 minus 10i, and then the negative gets distributed. Minus 7 minus 2i. And then I'm going to combine together all the terms that do not have an I. So negative 4 and negative 7 would be negative 11. And then 6i minus 10i, that's negative 4 minus 2 is negative 6i. So remember, standard form puts the I at the end. Okay, number two, what you are not going to do is distribute that exponent, right? We're going to expand and FOIL these. So this would be 5 plus 2i. This is not the one we use the shortcut on because they are the same sign. You can only use the shortcut if it's the same with the opposite sign. So I can multiply, the 5 times 5 is 25. 5 times 2i is 10i. 10i again. And 4i squared. We could have used our special product shortcut, right, which is square, square, and then double the product. But you can't use the a squared plus b squared. So then this becomes a negative 1, and that becomes a negative 4. 25 minus 4 is 21 plus 20i. Yep. It's in standard form. I is supposed to come last. Yeah. All right, 3. Now you've got the I in the denominator. You can't keep it there because that's irrational. So I multiply by the conjugate, which would be 4 plus 3i. So in the numerator, I'm going to FOIL this out. 3 times 4 is 12. 3 times 3i is 9i. 2i times 4, 8i. 2i times 3i is 6i squared. The I squared is going to become a negative 1, making this minus 6. 12 minus 6 is 6, and then 9 plus 8 would be 17i. That's the numerator. The denominator I can FOIL out, or I can use the shortcut because these are conjugates. A squared would be 4 squared, b squared would be 3 squared, and then just add them. So 16 plus 9 is 25. And then that answer is fine with me. Like, you can keep it together like that. WebAssign was picky, right? Did have to separate it out. 25 or 6 plus 25 plus 7i over 25. That's how, like, the WebAssign format wanted it. But I'll take either of these. Okay. You can keep them together or you can separate it out. Questions on that one? All right, 4, first thing we got to do is take the negatives out. So this becomes I square root 75 plus I square root 15 over square root 3. Now, because 3 goes into both the 15 and the 75, you can actually reduce it before you continue, or you could continue and then reduce it. It doesn't matter. But only because it goes into both, 25, can you reduce it before you simplify. So this becomes I times the square root of 25, or 5i, plus I square root 5 over square root of 1 here would just be 1. So I could get 5i plus I square root 5. And WebAssign will even take it a step further and take I out, like do I there, and then 5 plus square root 5. But I don't care. Either of these is fine. If you had like simplified over here first, I would have gotten, well, you still would have had to simplify at the end anyways, but because it would have been 5, 3 times 5, no, sorry, 3 times 25. And then that's 5 and 5. That brings to the outside 5i square root 3 plus I square root 15 over square root 3. So we would then have canceled it at that point either way. So your answer should be that same format either way. Yep. You don't have to. I'll take either answer. Yeah. All right, number 5. So the higher the exponent, the more you want to shortcut it. You don't want to write out 27 i's, right? So we take out the extra odd I, and I would rewrite this as I to the 26 times I. And then I would rewrite I to the 26 as I squared raised to the 13th power. And what is I squared? Negative 1. What do I have if I have 13 negative 1s? A negative 1 times I. So this would be negative I. I made that video so long ago, it feels like this is so long. Any questions? Okay, so let's do the homework questions. All right, this was 9. So it's addition, which means I'm not going to FOIL it. Be careful because people make silly mistakes like that. I have to take the i's out. Break down that 8 to 2 and 4 and 2 and 2. The 2 comes to the outside, so I have negative 3 plus 2i square root 2. I can get rid of the parentheses because it's just addition. Plus 5, and then this is 2 and 26, 2 and 13, so I can bring a pair of 2's to the outside, minus 2i square root 13. Group together the real parts or the ones that don't have the I, and then you can either leave it like this, or you could take a 2i, well, you could take a 2 out of the front. You could take a 2 out of all of it, and then group together the 2 i's on the end. So I don't care which way you write it. You could either just leave it like that because it's less work, or you could do 2 plus and take out a 2i. Like that. It doesn't matter. I would say the circled one is less work, so you might as well leave it. You just can't combine something that has a root 2 and a root 13. All right, this is 24, so the denominators are not like, right? You have actually options here. I could either combine them into 1 by giving them a like denominator, or I can rationalize them separately and then combine them, okay? So if you rationalize them separately, you're going to multiply by 8 plus 2i. And that's 8i plus 2i squared. This becomes minus 2. So I get negative 2 plus 8i over, shortcut here is 8 squared plus 2 squared, 64 plus 4, so 68. And go a step further because they're all divisible by 2. 1, 4, 32. So negative 1 plus 4i over 32 is the first one. Second one, I'd multiply by 8 minus 3i. So the numerator here, 16i, negative 6i squared becomes plus 6. Oh, let me see if it reduces first. Over 8 squared plus 9 squared, plus 3 squared. 64 plus 9, which is 73. Okay, I'm not going to simplify, so I would keep it this way. And then, did it even have you combine it into one step? Yeah, so you got to find the least common denominator. What was it? 7225. That's fun. It won't be that big on your test. Because you multiply by 32? Yeah. And then you have to do the top 2. Good news is it won't be that big on your test at all. And then you got to get it into 1. Sophia. Yeah, I was saying you had choices. You could have also just like multiplied this one by that one and this one by that one and then combine them into 1. But you still have to get rid of the i's at the end and the bottom. So it's messy either way.
Could you keep it like that, the 2 fractions?
So, I mean, it depends on how simplified it would keep. You won't have ones that have different denominators that you have to combine. On your test, you're going to have like 1 where you have to like rationalize it, not where you then have to combine. Okay. Yeah. Technically, no, because it's not as simplified as it can get.
Is it test for this quarter or the next quarter?
It's this quarter. It's your 3rd test. Yeah. All right. Then you had these, right? You had a conjugate of a like an actual real number, and then the conjugate of the one that had the negative underneath. So the conjugate of this, the conjugate is the change of the sign on the imaginary part, right? So this is really like a plus 0i. The conjugate to that would be square root of 6 minus 0i, which is the same thing. So it's just square root 6 times square root 6, which is 6, okay? The purpose of a conjugate is to get rid of the imaginary part, but there wasn't even an imaginary part in that one. The other one, though, becomes I square root 20. And then you can simplify that first and then multiply by its conjugate, or you can multiply by its conjugate, which would be negative I square root 20. So then it's negative I squared times 20. Negative negative 1 times 20, which becomes positive 20.
Thank you.
You're welcome. So it's tricky because they didn't have, like, one was missing the imaginary part, one was missing the real part. But it's the same concept. Like, if it's confusing, just put a 0 into one you're missing. All right, this is 28. So now we're multiplying, but I'm going to get the I out first. So I square root 7, 8 minus I square root 14. Then FOIL. So 24 minus 3I root 14 plus 8I root 7 minus I squared times, and I'm going to keep it separate because I'm going to end up simplifying this, square root 7 times 14. So 24. These do not have the same square root, so I can't combine them. This becomes negative 1, but this breaks down to 2 and 7, which means I can bring out a 7. So now I've got negative 7 times negative 1, which is plus 7 square root 2. And then it literally stays that whole thing. Actually, standard form will put the i's at the end. But you put the I at the end?
Yeah, I put both eyes at the end.
And maybe it tried to pull the I. Did you look back? I bet it pulled I out. Like, I bet it did this. WebAssign gets weird on the format of these. Yeah, I bet it pulled the I out. Actually, maybe. So then it would have been 3 root 14 minus 8I root 7. No, not 8I. Like, I would look back on their answer. I wonder if that's what they does weird stuff like that. I wouldn't expect you to do that. Yeah. This is when WebAssign and I don't agree on the I format.
Yeah, I did it like 6 times.
It's super frustrating. That's why you're not supposed to do that. That's why you just, like, do the work, don't stress out, and then let me give you back the credit. I know you need the little green check, but it's okay, right? You still get the score. Is that the last one? Yeah. Okay. So we're going to finish. The good news is not a lot today. Okay. And it wraps up. Like, it's in this one section. So, like, Sebastian, we're kind of reviewing today already because in this one section, we're going to do complete the square, and we're going to do the square root property, and we're going to do quadratic formula. So you're doing it all in this section because now these answers are going to have i's. So all the things that we did up to this point when we're solving quadratics, you're now going to bring in the opportunity to have complex numbers. So our answers are going to have i's in them, okay? Huh? Oh, okay. So we're going back through all the ways to solve quadratics.
In the test, do we have like the option to do it in quadratic formula?
It's going to be both. Like, there's going to be times where it's going to say solve by completing the square, and then or solve by factoring, or it will just say solve and you get to choose. So you're going to get a little bit of both. So these are all going to be quadratics, okay? Which means you're either going to solve using one of these. The even root property, which is the square roots, and we have to do the plus and minus. The complete the square, which God knows we know what that means, right? And the quadratic formula, which is the negative b plus and minus the square root of b squared minus 4ac all over 2a. The only thing you can't do with complex numbers is the factoring, because you can't factor a non-real number. Everything else you can still use. All right, so we're going to go piece by piece. We're going to practice at least one of each different kind just so that we get the practice on it. But in a situation like this, it just says solve, which means you could literally use whatever you can use. Doesn't mean you're always going to be able to use all of them, but at least you can choose. So if you look at one, what would you normally try to do there first? I would probably have square root of both sides. That is not to say that you can't expand that as x minus 2 times x minus 2, FOIL it out, and then use quadratic formula or complete the square. You could have done that on this one, right? But this is I would say this is set up for you to do the square roots. So I'm going to square root. You're welcome. I'm going to square root, and I'm going to not forget to put the plus and the minus at the front. I get x minus 2 equals plus and minus the square root of negative 20. So now what? Take out the I. X minus 2 equals plus and minus I square root 20. Break that down into 2 and 10, 2 and 5, which means I can bring the 2 out with the I. Plus and minus 2I square root 5. Then what? Good. So I get x equals 2 plus and minus 2I square root 5. And you can leave it as plus and minus. You don't have to separate it. And tonight's homework is a PDF, so it won't yell at you based on format. All right, so same thing for number 2. I would say that this is already set up hinting for you to square root. I'm going to square root both sides. I'm going to put a plus and minus at the front. 3x minus 1 would equal plus and minus. The I comes to the outside. And this would be 3 and 16 or 4 and 4. So a 4 can come to the outside. Then I got to add the 1. So 3x equals 1 plus and minus 4I square root 3. And then divide everything by 3. And that is a fine format to leave your answer in. Okay, you will also see it split up like 1/3 plus and minus 4I root 3 over 3. You also see it like that. Those are both right. In my opinion, I will leave it like this because it's less work. And it's still right. Questions on those? All right, 3. So what would you try to do first? You could try a formula, yeah. Okay. What I would say is see if it's factorable first, because if it's factorable, it's obviously going to be the easy way to go. And these are going to get meshed in together on your test. So you're going to get some that don't have i's. You're going to get some that are factorable. So if you can factor it, try it. There's obviously no factors of positive 5 that sum to 1, which means our other options are complete the square, quadratic formula, okay? So we're gonna do quadratic formula, but you could have also completed the square in this. So A is 1, B is 1, and C is 5. -1 plus and minus the square root of 1 squared minus 4 times A times C all over 2 times A. I get -1 plus and minus the square root of 1 minus 20 over 2, -19. And the 19 does not break down, but you have to bring the I out. And again, you could split it or keep it together. Either of those are right. Questions on that one? Yeah. There are going to be some that say have to, and then there's going to be some that say just solve. Yep. So I'm going to do this one, complete the square. Okay? So just so we can review it. There are no factors of 10 that sum to, like positive 10 that sum to positive 3. If it was a -10, I could have done 2 and 5, right? That was factorable, but this is not. So I'm going to do complete the square. So we're going to group together those first two terms. We're going to push the 10 to the other side, so it becomes -10. If there was something on the front of the x squared, I'd divide everything by it, but there's not. There will be on your test. I'm going to take that 3. I'm going to divide it by 2 and then square it, and I'd get 9/4. Add 9/4. Add 9/4. Square root the x squared. Square root the 9/4. Take the sign from the middle. Put it in parentheses and square it. And this would be 40 over 4. -40 plus 9 is -31 over 4. Now I square root both sides, putting the plus and the minus in front. And there's the overlap between yesterday's section and complete the square, because now what's underneath is a negative number. So I got to take out the I, and this would be the square root of negative 31 over the square root of 4. So that then becomes 2. Be careful. I think we made that mistake before. Make sure that when they're under their square root, they're both under the square root. And then just subtract the 3 halves. So I'd get negative 3 halves plus and minus I square root 31 over 2. If you had done this using the quadratic formula, you would have probably had that together. Negative 3 plus and minus I root 31 over 2, which is, again, why either of these are fine, okay? Because the different format might lead you to a different, or the different process might lead you to a different format, but it's still the same answer. Questions on that one? All right, again, same set of instructions, solve, which means you get to choose. So how would you do 5? Okay, I would subtract the 25 and then square root. You could have also done the quadratic formula. Your b would have been 0, okay? And I'd get x equals plus and minus 5i. All right, you do the rest of these, and you get to choose. Choose with. All right, so 6, I would again try to factor it. It is not factorable, so then I mean, it's up to you, but I'm going to do complete the square just so we practice it one more time. I probably would have chosen quadratic formula over complete the square, but you're going to have to do it, so you might as well practice it, okay? So we're going to group together the first 2 terms. We're going to bump the 9 to the other side. This time, it's easy. We take the 2, divide it by 2. That's 1. 1 squared would be 1. I add 1 here, I add 1 here. Square root, take the sign from the middle, put it in parentheses and square it, and I'd get negative 8 on the other side. Then I go to square root each side, putting a plus and minus in the front, and I get x plus 1 equals plus and minus. The I would come to the outside, that's 2 and 4, or 2i square root 2, and then just subtract the 1. So if you had done the quadratic, all the terms would have been divisible by whatever's on the bottom, which is 2. So it should have simplified to be the same thing. And again, it's totally fine to keep them as plus and minus, okay? Number 7, I would have done the square root. So I would have subtracted the 9, divided by 25, and I get x squared equals negative 9 over 25. Square root both sides. Plus and minus, and x equals plus and minus 3i over 5. The I could be at the front, the I could be at the outside, doesn't matter, but as long as you've simplified it, and don't forget the I. Yeah?
You could just square root from the 25x squared, right? You have to divide by 25.
You have to, you mean after you move the 9, though? Yeah, that's fine. Yeah, was that all those hands? Yeah, okay. Yeah, that's fine. All right, number 8, divide by 3. Plus, or no, not plus or minus yet. Negative 16 over 3. Then square root, plus and minus. X minus 1 equals plus and minus the square root of negative 16, which is 4i. But the square root is also in the denominator, so it would stay as square root over square root 3. Can you leave it like that? No, you got to rationalize it. So both the top and the bottom get the square root of 3. I could also add this 1. So I'd get x equals 1 plus and minus 4i root 3 over 3. If you wanted to combine them into 1, so if you like, what you could do, you could expand this x minus 1 times x minus 1, FOIL that out, and then distribute the 3 in, move the 16 over and done quadratic formula, which is fine. They would have given you the same answer. This format would have changed. It would have been 3 plus and minus 4i root 3 all over 3. So just realize those are both right. I don't care which way you do it.
Can you do the quadratic formula for 6, please?
Yeah, 6. Okay. So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a, negative 2. 4 minus 36. So that's 2 and 16, right? So negative 2 plus and minus 4I root 2 over 2. And then 2 goes in itself once and 4 twice. So you should have gotten the same thing.
Thank you.
You're welcome. Continue.
For 8, I moved the 1 over and then I rationalized and I thought it's
You move the 1 over and then rationalize. So from here, you're saying it's x equals 1 plus and minus 4I over root 3, like that?
Yeah, but I put everything over.
Oh, careful. It's not. The 1 is not. Yep.
Thank you.
You're welcome.
Are you going to be dropping our lowest quiz?
Yeah, so I published your grades so you can see those quiz grades now, but then today I'll drop your lowest. Yep. But wait, we're not done. I know it seems like we're done because the notes are done, but we're not done. So these are perfect cubes, and we are used to factoring them, right? But we haven't solved them using, which will be factoring, and also the quadratic formula. So when you have a perfect cube, if it had said find all the real solutions, I would have added the 64 and I would have cube root both sides, and you literally would have just gotten 4. But as soon as you start to combine in here imaginary roots, you have to factor this first and then solve, okay? So same process for factoring the perfect cubes as we were used to. I'm going to cube root the first one. I cube root the second one. I put those together in my first parentheses. I square the x, multiply the 2 together, and square the 4. And then what's my signs? Same, opposite, always positive. So the 1 on the left, I can literally just set equal to 0 and solve. But the 1 on the right, I can no longer solve that way. And it's not factorable, okay? These don't factor any further. Which means my options are quadratic formula or complete the square. Which would you pick? Quadratic formula. Okay, so A is 1, B is 4, C is 16. Negative B plus and minus the square root of 4 squared. Minus 4 times A times C over 2 times A. And there's my imaginary root. So I'm going to keep going because this is 3 and 16 or 4 and 4. And then this goes into each of these. So when we're solving, 4 is an answer, and so are these. So it's 4, negative 2 minus 2i root 3, negative 2 plus 2i root 3. Or you could have left it together and done plus and minus. I don't care. Just also don't forget your 4. All right, you do B. What's the cube root of 216? 6. And if you didn't know it, you could break it down, remember? Like if I was trying to figure out the cube root of 216, hopefully now we just remember it. But I know 2 goes into here, 108. I could keep going, 2, 54, 2, 27, 3, 9, 3, and 3. And I can bring out 1, 2, because I need 3 of them. And I could bring out 1, 3, and there's my 6. So again, they're not going to be too big. I would say probably 6 cubed would be the furthest we would go. But if you got stuck and you couldn't remember, then that's how you could figure it out. So cube root of the x to the third is x. Cube root of 16 is, or 216 is 6. And then it's x plus 6, x squared minus 6x plus 36. So this set equal to 0. That's your negative 6. And then negative b would be a positive 6 plus and minus the square root of b squared minus 4 times a times c over 2 times a. 36 times 4, negative 144. One, oh, 8. I comes to the outside here. I have a pair of 2s, pair of 3s, 1 3 left underneath. And then 2 goes into all 3 parts. And don't forget about your -6. All right, so tonight's homework, did I publish it? Let me have, yeah, is a PDF, okay? And it'll say, like, basically solve all the different kinds. A lot, I think almost all of them have I's in the answers, okay? So there's the overlap. But the good thing is you're being forced to practice. Definitely practice at least one complete the square with a non-even number in the middle because it's going to happen. Definitely practice at least one quadratic formula. And then obviously the square roots, I think those are set up as square roots. I wouldn't choose to do them any other way.